Today we're going to learn how to factor out using GCF. First of all, GCF stands for greatest common factor. A factor is a variable or a number, something you can divide by. Now to find the GCF factor, we will start off with two sets of numbers, 20 and 16. The factors of 20 are 20, 1, 2, 10, 4, 5. And the factors of 16 are 2, 8, 4, 4, 16, and 1. If you multiply two of these numbers, it would give you either 20 or 16. For example, 20 times 1 equals 20, and 2 times 8 equals 16. In this case, 4 is the GCF, because 4 is a number that both sets of both 20 and 16 have among their factors, and it is the biggest one in common. GCF in polynomials. Now to find the GCF in a polynomial is a little bit trickier. Here we have a regular polynomial, 5v to the 5th power plus 10v cubed. First of all, 5 is the GCF between 5 and 10. The GCF of 5 and 10 is 5. Then to find the GCF between the v's, we need to first list all of the v's between the two numbers. We leave the numbers out for a little bit, and then we see that 5 has 5 v's and 10 has 3 v's. So in common, they both have 3 v's. So it would be v cubed. So the GCF of 5v to the 5th power plus 10v cubed is 5v cubed, because 5 is the GCF between 5 and 10, and they both have 3 v's. To factor it out, you need to divide the GCF, so in this case 5v cubed, by both numbers in the original polynomial. Tip: when two variables have the same base, you subtract them. So you subtract the exponents. So here are the results. You divide both of the numbers by the GCF, and those would equal the first one. We subtract the exponents, 5 minus 3, and we divide 5 by 5, so that would equal 1. So the final answer would be 5 minus 3. 5 minus 3 equals 2, so it would be v to the 2nd power. Next we do the same with 10 over 5. We subtract the exponents of the v's, and we get 0. So it will be v to the 0, so there will be no v at all. And 10 over 5 equals 2. So it would just be a 2. So finally we have 1v to the 2nd power plus 2. We put that in parentheses and put the GCF in the outside. So that would be your final answer. So we will here do one last problem. We've got another polynomial, but this time with 3 numbers. 15n cubed minus 3n to the 2nd power plus 12n. So first we need to find the GCF of the polynomials. The GCF is 3. The GCF is 3n. So we have the problem and divide the GCF by the 3 numbers. So 15n cubed divided by 3n, 3n squared divided by 3n, and 12n divided by 3n. So this would equal 5n squared minus 1n plus 4 in parentheses, and the GCF 3n outside. The end.